sentence, and I'll be happy to answer. If not, later on, or after that, and the time I'll hang around here. So, Firebase. So a little bit of show of hands. How many people have heard about Firebase? Not surprising. How many people actually use Firebase in production? So that's a smaller number. And probably the smallest number, how many people have ever used Firebase function in production? Oh, that's a really low number. And I guess if I ask how many people have used Cloud Functions version 2, maybe one person? No? Okay.
Just you.
Probably just me. No?
That's how special you are.
I'm just an early adapter. I like to think everything. So a little bit about Firebase. So Firebase was not made by Google. It evolved from a company called Envolve in 2011 and created a new company. The first product was real-time database, which is one of the major components of Firebase till this day. Think of a real-time database like a normal database, document-based database, or whatever, but you can trigger callbacks on specific events. And that was the selling point, especially if you're going to build mobile application that you don't want to pull the database all the time for changes, or you want to connect. So you register for those callback, and then you can create your own workflow based on events that were happening on your database. So you just register. Or the classic textbook example is chat application. So you send a message, it's in the database, now the recipient gets a notification and can pull the data. And you don't even need to be connected to each other. You can synchronize application data across multiple mobile devices, both Android and iOS. And basically, it assists people to write their own mobile application. If you remember, there also was a product called Parse, later on acquired by Facebook, and then they killed it. And there were the two major components if you wanted to build, two major play if you wanted to build your own mobile application without the need to write or to delve too much into the backend stuff. So they started with two major products, hosting and authentication, and more feature when coming up. One of the product is Firestore, which is basically, if you're familiar with AWS, it's the equivalent for DynamoDB, document store, cloud-based, managed, highly scalable. There's Cloud Function, remote configuration, which lets you do a real-time configuration of your mobile app just by setting some flag in the database. A lot more analytics and much more. I'm not going to dive into all the Firebase offering. Okay. So what are Cloud Function? So Cloud Function, if you're familiar with AWS, the best equivalent is Lambda. Basically, you've got the function, it stores in the cloud, as its name says. You can call it and get a response. Why use Cloud Function? It doesn't matter whether it's Firebase or Google Cloud Function or AWS. It's small, it's only function, it's stateless, and you don't need to manage it. Once it's up, it's managed, auto-scales, etc. by your cloud provider. So that's, again, take the burden of operating a backend system. So yes, Cloud Functions are not the answer for anything, but there's a lot of use cases that you can use them. So Cloud Function in Firebase or at Google, can be called in different ways. You can call them either directly explicit via HTTP call, so you're performing the HTTP call, etc., and the server got the regular HTTP payload, or you can call it directly from application using the SDK, and then the server will get an object that it can work on it. But basically, the functions are the same. And there's a bunch of triggers, from the real-time database triggers to remote configuration trigger, authentication, etc. One of the nice things, since you're using a framework, you can separate between the thin layer that accepts the call, meaning either from the web or from the trigger, and the actual code in the function. So you can reuse what the function is doing and activate it with different payloads based on different cases. So you only have to write the function itself, get the data, and then call the actual stuff that you need. So, Cloud Functions version 2. It's now public preview. It's production ready. Not all the features are yet ready, mostly around some kinds of events, but it's there, it's running. The infrastructure is more robust. You have more control about the function runtime, about performance, stability. You can select different types of machine to use it. And it's powered by two interested subsystem or infrastructure. The first one is Cloud Run, which I'm going to touch about a little bit later on, and Event-on-C. So, and this is a thing that I've noticed in a few years back. Google has some serverless or application serverless options, starting with App Engine, whether the standard or not the standard. They have Cloud Function, they have Firebase Cloud Function, they have Cloud Run. But the thing that has been noticed in the last few years, there's some consolidation. In the past, each of those services uses its own mechanism or infrastructure to provide a service. But Cloud Function and Firebase Cloud Function are moving to use Cloud Run as their infrastructure. So it's going to be consolidated. I'm not from Google. I don't know the plans, but it makes a lot of sense. Same infrastructure, very stable, very reliable, and ways to operate it. And Event-on-C is a framework to consume events, either custom events or predefined events by a cloud provider. So, Cloud Run. Cloud Run is a managed compute platform that automatically scales your stateless containers. And Cloud Run is serverless. It basically abstracts the infrastructure management, so you can focus on writing your application and not operating. Cloud Run is built upon an open source project called Knative. Anybody heard about Knative? Yeah.
I have a question.
Yes.
How is this different from uploading my service or function on a Google Cloud virtual machine, let's say?
If you load it on a virtual machine, you'll need to take care of the availability, scalability, and manage it by yourself. And
Scalability we can take care of using...
Yeah, there are tools to do it, but still you need to define the auto-scaling group, you need to define where to scale. You can scale to zero. And one of the advantages of function that you can scale them to zero. Of course, paying the cold start cost.
The other big thing is he cannot have zero downtime, right? Cloud Run will only happen when the event happens, right?
Yes and no. So in Cloud Run and in Cloud Function, basically, if you are not using the function or your code, the function is going down and will start the next time somebody called it. But you can say, I've got a very high available application and I want to minimize the zero time and I'm willing to pay the cost. So you can say, I want to have X amount of minimum instance up in there all the time. So it's up to you. You have full control of that. But one of the things that if you don't use it, you won't pay. But while using virtual machine, you're paying them whether or not to use them or not. So, and you need to manage them, and you need to back up them, et cetera, et cetera, et cetera. And you need to deploy them. So there's a lot of overhead running on virtual machine. I'm not saying that, but again, Cloud Run, as I mentioned, it's stateless. So if you need something with state, probably Cloud Run is not the best solution for you. Also, you probably can hack it. And now there's a beta feature of affinity for session, but it's still in beta. I haven't tested it yet. That might be solve some of the ability to do some stateful operation. So Knative is an open source project that runs on Kubernetes and basically lets you to build serverless function on top of Kubernetes. Google version of it, which basically it's the same code, but they took the burden of operation upon them. You've got two versions of Cloud Run. The one is the fully managed one. Basically, you give Cloud Run a container, and Google will run it on top of their infrastructure and will take care of anything. And you will be only paying for what you're using. The second option, let's say you've got some security or more concerned about privacy, and you already got a Kubernetes cluster that is up and running, you can deploy Cloud Run on your Kubernetes cluster, and basically, and the interface is the same. So if you're already using the machine, then you don't have any extra cost by operating Cloud Run on top of it. So that's up to you. The interface is the same. I wrote that those are 4 years old, 3 years old, 2 blog posts. One of them, when Cloud Run went out, I did some benchmarking and comparison about it. And the second one, hacking Cloud Run. One of the limitation of Cloud Run and also Cloud Function, the first version, that if nobody called the instance of Cloud Run on the function for 10 minutes, 15 minutes of idle time, they took it down. So you couldn't use it for long running operation. And in this post, I say how we can bypass that. Basically long polling. If you want, you can read it. Okay. Event Received. Event Received is the other mechanism that basically powers Cloud Function, and also, again, the consolidation at Google, not just with Cloud Run as the operating the infrastructure layer, but also as Event Received as the event.
Is Event Arc a product or it's a concept?
Actually both, but it's a concept, but it's implemented.
So like you have Firebase on Google. So there's something on the Google console, there'll be Event Arc too.
Yes, so you can create your own custom events, or you can use a lot of predefined events, and I'm going to show some code later on. So basically you've got producers, that create all kinds of events. Some of them are predefined. Here we can see Google Cloud Sources, or your own application can publish it, mostly to PubSub. Then there's a framework, and then you can be a subscriber or a consumer for those events. And that's basically allows you to do lots of things, a lot of customization without the need to take care of how do I pass the messages from one system to another. The framework will take care of it for you.
So is this like the equivalent to like the Azure Event Hub?
I'm not familiar with Azure, sorry.
Or this was something on AWS, right?
So it's, the power underneath is PubSub. So I guess you can build some kind of a system on top of any queuing system, either Kafka, SQS, or Azure. But it's basically Google send all those events into those systems. So all the predefined Google events. So it comes already.
Can it also store and replay? No.
No. So that's once you consume it, it's gone.
Okay, got it.
But it's battery included, so you can use it from a lot of things from day one. So you can events can be sourced from Google Storage, BigQuery, Firestore, and currently about 60, give or take 60 Google Cloud sources. Okay. So beside the fact that all the infrastructure is new, there are two major things that are new. The second one, it gives you better control about core setting, etc. It's nice, but I think that the first one is more important. Usually, or historically, when you activate a cloud function, it could be Google, Azure, AWS, or whatever, you call a function, the system will spin up an instance, process the data, responds to you, and that's it. If you need to handle 2 requests, 10 requests, 50 requests at the same time, the system will spin up as many instances as needed.
So one question is, the first says a function instances can now execute more than one request at a time.
Yes.
So it creates multiple instances of the function?
No. Think of it like your application, which is Dockerized.
Right.
and your application has got only one endpoint, X. But if you have a web application, any normal web application can handle multiple calls of the function at the same time. This is what's happening. Basically, Google, you created a function. Google creates a Docker image for it, and give it to Cloud Run. So, and you can define, based on your application, the concurrency level. So the default is one function without the need to spawn a new instance can handle about 80, if I remember correctly, 80 concurrent requests. This is configurable on the application, on the Cloud Run and Cloud Function setting, and also you can select the kind of machine that you're using. So if your application needs more memory, spin up a machine with more memory. If your application needs more CPU, you cannot mix and match and predefine machines, but this gives you a better control, more economics, and also this removes the needs of cold start for function. Because if the container is already up, you don't have to wait a few seconds or whatever time it needs in order to serve the next function. So those are the two, from my point of view, those are two big selling points for those functions.
Excuse me, is the cold start on the order of 2 seconds? Or?
It depends on what your application doing. If your application got a lot of initialization code, let's say if not, it could be more, but that depends on you. And there's a way, I'm going to show you a snippet of code to how you can reduce it.
What's the limit, like in AWS Lambda, right? You can have up to 10 CPUs.
I don't remember on top of my head.
And like 10 GB of space, right? So for this function, is there any limit?
Yes, but I don't remember it on top of my head.
Okay, sorry.
I think it's 8.
Okay, makes sense. Okay, so I mentioned before that I did a blog post on how to hack Cloud Run. So Cloud Run used to have 15 minutes timeout. Cloud Function had 9 minutes, different technology. But now you can, it's an hour. So it should be good enough for most applications to handle. Even if you write very poor code and slow, I guess most cases you won't need an hour to handle most of the cases. Again, this is not a magic, Cloud Function are not the magic bullet, but they can solve a lot of use cases. Another thing that makes the developer or DevOps or whoever deploy them manage your function a little bit easier is now that they default into the default compute instance service account, so a little bit easier, less steps, etc. So it works out of the box, and a lot of new triggers were introduced, and we'll touch it about. So this is like a shopping list of triggers. I'm not going to read it because I guess everyone here can read. But there's a lot of variety and a lot of ways to call. Some of them are based on event RC, some of them are not.
So these are new, or some of them are old?
Some of them are old, some of them are new, yeah. What's not supported yet? Firestore, Firebase Authentication, and Google Analytics. There are some triggers that are for Firebase Authentication that are already, you can use them via event RC. Those two are not, but I guess they'll be coming. Firestore, I guess, also will be coming. The real-time database is there. So if you want to trigger your function based on events that's happening in the real-time database, you can. The ones in Firestore are not. I'll be waiting for them because they're very useful to use the Firestore event to create your own logic. I don't know if you want to delete something upon an event or do other things. But they're becoming, it's still in public preview. So we're going to see some code today. Full disclosure, I'm not a JavaScript or TypeScript programmer. It's not my language of choice, so please don't critique my code, okay? And most of the code that I'm going to display today is taken out from Google sample, etc. This one was taken from a real-life project a few months back. Some friends of mine and me, we created a service. We closed it because we didn't have a good product to market fit, but I took that option to migrate it from Cloud Function V1 to V2. And this is a simple function, basically getting the last post of a user. So in version 1, we needed to change the counts from V1 to V2, and a little bit of the function signature. And you can see that I'm getting the data not from the context, the authorization data, but from the request itself. And that's it. That's all the change. Okay. And touching back on cold start, etc. This is a trick. It worked with V1. I haven't tested it if it's really anything on V2. I didn't measure it, but this is a way to delay your load, the function or the initialization of the function only to the first time that it's called. Because in version 1, you've got an index file with all the function definition, and the system is loading it the first time. So every initialization that you have to do for function, it's done at that time. So there are a few tricks in order to delay it. One of them is if there's commonality between functions, do the initialization on global level, so you'll save some time. And if you have some function-specific initialization, don't do it when the function loads, but wait until it actually called. So wait until the real function is actually called. And this is just a wrapper around the real world design. Never tested it with V2 if it has an effect or no, but the code is there, so I'll show it. So you can see moving from V1 to V2 is basically almost no-brainer. You can write some script that will do it for you. So as I mentioned before, you can call the function directly, either from your app, via the SDK, call it via HTTP request, use Cloud Task to enqueue function. So you can create a task in Cloud Task, which is, again, a fully managed service by Google, and the function will pick it up and do it, or using a Cloud Scheduler to run it on Scheduler by supplying, you create the schedule. The syntax is like regular cron with all that stuff. And when it's time to, and you supply it with an endpoint, and when the function, when the timer expires, then your function will be called. Okay, let's go back a little bit for triggers. So as I mentioned before, a lot of ways to trigger those functions. Okay. Anyone here heard about Firebase extensions? No. Okay. This is I don't know why, and not related to Firebase functions. I don't know why not a lot of people are aware of this, of the Firebase extension, because that can make your life easier and save you a lot of time while developing an application. Basically, there are prepackaged solutions that hooks like that into your Firebase project and can save you a lot of time coding and managing, etc. So you install them. There's a nice marketplace and the UI, and they can perform tasks responding to HTTPS requests, schedule event, or trigger from other Firebase or Google product. I use them in the project that I mentioned before, that actually makes my life easier. So what kind of extension do we have? We have extension that can stream your collections to BigQuery. So you can say, that collection, I want to, for example, users. I want to send all my user extension to BigQuery, and then it will run some analytics on top of it. You can resize images. Some of the extensions basically are done by Google and some by third party. You can delete user data upon an event. Trigger email by SendGrid, using Stripe, Twilio, and many more. Also, you can have multiple instances of the same extension, each one configured in a different way. So you can have multiple instances of streaming collection to BigQuery for each collection that you have, whatever. It's very, very helpful. So there is an extension by Google. It's that basically when you upload a file to a specific GTS bucket, that the extension automatically find out whether or not it's an image. Then you can define like resize it, name it, do some manipulation, etc. It's nice. But let's see what we can do after the extension is run. So the mechanism that you see here is basically upon event RC. This is the name of the event. The convention is a Firebase extension. The name of the extension, the version, and the complete is basically you get it, the event once the resize is done, and then you get all the data out of the event payload. And in this case, we are writing it into Firestore. But you got everything for free, and you can do whatever you want. This is a demo code by Google, not real production code, but I think it's demonstrate the point. Okay. Another interesting thing is authentication. As I mentioned before, not all the events on authentication are yet ready to production, but there's two events that you can use. You can basically use some authentication trigger. There are two different triggers before a user is created. So a new user is created and saved to Firebase authentication. And before the token is returned to the user saying, okay, you're good to go, you can do some logic. You can say, okay, if that user comes from that address, I don't want or whatever you want. And the other one is a little later in the process before you sign in. So two different tokens. And again, the code. You register to the event, get the data, and do whatever you want. Again, very simple, very easy. And I think going through the code, you see there's a lot of commonality about the way that Firebase Cloud Functions and Event RC are handling events. Once you write your first function, the rest of them, at least in terms of boilerplate code, etc., it goes like that. You can focus really on the stuff that you know how to do, your application, your competitive advantage.
Question of you. So are you saying like that this piece of code, like this 6 lines of code, whatever is all you need to deploy a service that run in the cloud?
No, this is the code that needs to get the function. Deploying it, it's like Firebase function deploy, whatever.
Sure. But that's it, right? That a server's running in the cloud, runs thousands of instances, just 4 lines of code.
Yeah. Of course, you can add, as you're sitting in the first example, you can select how many servers you want to operate. But again, it's annotation, etc. But plain and simple, just that.
Like AWS Lambda, right? You say the maximum concurrency is this much. But if your function is not called, that server will still keep going on? As long as timeout happens?
Google will take it down after timeout, etc.
Let's just give an example. Suppose I have a timeout of 1 minute.
Mm-hmm.
Okay, and in an hour I got 10 responses. Sorry, 10 requests. At like minute 1, minute 10, minute 15, and whatever. 10 responses, so timeout. So will I get charged for like 60 minutes or
No.
for 10 minutes?
No, if you will charge, the model is charged about CPU utilization.
Right, CPU an hour.
Yeah. No, that's really the level we don't want to take down. So it's very interesting to take the function down if it's not operating.
Yeah. You're using a personal account.
Yeah, but personal account, I think Google are pretty much generous with how many functions you can use. I'm going to consulting for some company, and basically all the development is almost free on top of Google. Yeah, there's a feature that they think it's very generous, especially if a 1 or 2 or 3 person shop starting your application. And again, if you were working on VM, it will take out of your credits. if you're working with stateless, with Cloud Function, or with Cloud Run, then there's a better, you've got a better utilization of your credits, let's put this this way. Okay, so in theory, I would expect that function version 2 will be faster, I think, more performance than version 1. Because you can run them in parallel, the infrastructure is new, etc. But again, for engineers, we like to measure things and not just assume. So I took some code from one of the Google examples and wrote it in, it's the same function. Basically, the code is doing the same. One of them is version 1, the other one is version 2. It just takes a date, format it as a string, and return it to the user. So no database operation, nothing, just a little bit of CPU, and that's it. And I put it to the test. So about test configuration, I use a tool called K6. You can run it on your machine. You can have a Docker image. You can run it. There's some free tier for the cloud service, so you can just run it on the cloud, and that's what I used. It's written in Go. It's very nice. I used it before, and the test was very simple. 20 virtual units, as they call it, running for 6 minutes, 30 seconds of ramp up, 30 seconds of ramp down, and in between, just calling. So one thing to notice, it's not related to performance or anything, is the URL. And if you're familiar with the convention, you can see that version 1, that's the region, that project name, cloud function, and the name of the function. Version 2, if anyone here used Cloud Run in the past, this is the URL that correlates to Cloud Run conventions. So you can tell a little bit about where the function is running by understanding the URL. So you can see that the number of functions was a little bit higher on version 2. But if you go into the details, you can see that minimum time was 10% faster on version 2. Average was 10% faster. Median 10%. Standard deviation was almost half. P95 was way better on version 2, and max time was 4 times faster on version 2. So version 2 is faster, not by much, but 10
What do you mean by
max time to respond to a call. So the longest that probably behind it it's a cold start, but not necessarily. So you can see that cloud functions are faster by 10%, which is nice, but they're more evenly distributed. So you know what you
times, right? The
max is 4 times, yeah, 4 times, and the standard deviation is almost half. So it's more reliable. You know what to expect, and you like predictability.
So this was the same code which apart from the APIs.
It's the same code, just one was wrote to version 1 and deployed to version 1, the other one to version 2. So nothing fancy. I think it's the plain and simple. I try to eliminate any noise from this test, and that's why the function is hardly doing anything. It's simple. I guess if I would run it longer with more concurrent requests, we would see some good difference because the fact that each instance of model can be, you can specify concurrency level. So if you can specify a higher concurrency level, you're eliminated more and more cold starts. If you're running a higher workload, then the difference will be much higher. Again, even with that simple measurement, you can see that if you're looking for performance and reliability and predictability, you should go to version 2. Yeah, everything was called same data center, same data center, same region, and they were called from the same cloud. Okay, so I tried to eliminate networking, as much noise as I can. I didn't test it from my computer. Okay, so also I tried to minimize that. And I ran it a few times, and it was consistent. So So a little bit how I'm doing. Okay, so I'm trying to talk faster. So I won't read it, but as I mentioned before, there's Firebase Cloud Function and there's our Cloud Function. And I think a couple of weeks ago, Google announced again public preview for Cloud Function version 2. Request time, as you see, go up to 60 minutes, the same as Firebase. You can select larger instance type, more concurrency, up to 10,000 concurrent user. Again, you can predefine the number of minimum instance, traffic splitting, which you don't have in Firebase Cloud Function. And it's nice because
How much like in AWS Lambda you can have 10 GB of temporary storage?
I'm not familiar, I don't know. But again, Cloud Function, you probably don't want to use storage, local storage, because you don't have access to it. So if you need some storage, you use it in there.
So like for example, you're doing that image, right?
The image is not done there. The image is done by an extension that works on top of Google Cloud Storage.
Oh,
Okay. One feature that is very good, traffic splitting. So you want to release a new version of traffic and want to make sure that it's working. Release it to 10%, monitor that. That's good enough. Move it to 100%. The way to do it actually in Firebase is a bit different. In Firebase, you can deploy to preview channel, but you cannot deploy function to preview channel. So there's some advantages of cloud. And again, the power and technology behind it, it's Cloud Run. Probably in the next couple of weeks, I'm going to try to do some measurement to see if there's any performance improvements while moving to Cloud Function version 2. Okay. That's basically Cloud Function. You can see that it's almost the same as Firebase Cloud Function. Instead of calling Firebase, importing from Firebase, you import it from Google Cloud, and then you register to an event and do your thing. This is one of the things that people used to ask me, why do I prefer working with Google than AWS? I said that Google have a very, and not just here, but a very consistent way to work via API. So once you master one set of API at Google, the learning curve for mastering the other set of API, it's pretty easy. They're very consistent, and also you can see that in the way of you've got different services. You basically call them. So I think that's my dog that I've been talking to in the last 3 years. It's a coffee dog. So feel free to ask me now any questions or catch me later on. I'll be more than happy to answer anything. Luke Skywalker, following on Facebook and Instagram. We've got 18,000 followers on Facebook. Yeah, I took a shortcut. While at Meta, I received each month some ad credit. So easy to promote his page.
Any questions for me?
It's like a general question. We have a lot of students in here. So, like, this is a lot of amazing stuff. Maybe they have, like, if you're a student and you wanted to get started trying to use Cloud Functions or Cloud Run, any idea what the best place for them to start would be?
Documentation first, just the documentation there, with link to a lot of samples. Well, I took most of the code here from samples because I wanted to make it very simple. And I think there are some online, I forget the name of it's not Code Lab, what's the name of
Cloud Skills Boost?
Yeah, there are some labs that you can take online. And again, if there are students here and want to provide, feel free to ping me. I'll be happy to help. I used to use, but I used to use App Engine a lot in the past, but I moved away from it. And they have different, the standard, a different standard, and the authoring was confused, and you have to do all kinds of tricks to work with things. And and if you're working with function, basically your code is very portable. Well, with the exception of the wrapping up the function with the calling mechanism. But when using App Engine, you have to use their own specific libraries, etc., which is not very portable and more vendor lock. It's better to that time, it was a great offer, but the world has been moving. Also, I think the pricing model is a bit easier when you're using Cloud Function, etc.
It looks like, so with all the different cloud functions becoming closer in feature set to Cloud Run, so
Yes.
what's your recommendation for use cases between like Cloud Run versus like multiple Cloud Functions behind an API gateway?
That's a good question. You have more flexibility when using Cloud Run. Some of it will come to Cloud Function, but it's lagging. So it depends. If you need a small, relatively set of function, go for Cloud Function. If you have a lot of function, that managing a lot of function in Cloud Function, again, sorry for the wording, it's a bit overwhelming because you need to deploy 10, 20, 50 functions, and you have to manage. If you Cloud Run, you can have your application in one instance, and that's it. So, like, it's the case of microservices. It's manageable until a certain number, but once you go to 100 to 1,000, you start doubting whether should I be moving to microservice architecture. But there isn't any one good answer. Again, it depends. But I would certainly start with, if I'm building a small application, I would start with the Cloud Function or Cloud Run. Just a while ago, it took me probably less than a day to migrate application that was running on a VM instance to Cloud Run. And I did it even to write a Docker file. And if you are not familiar with Cloud Build Tech, I suggest that you use it. Cloud Build is a service by Google that builds your application. You can give him a Docker image to build, but if you're using the pack option, basically, you don't need to do anything. It will look at your application, understand, and create its own easy-to-use Docker file behind the scene. So no custom Docker file, no separation between build and temp, etc. All taken care of. So again, another. So I think we're out of time. Feel free to catch me. I'm here, happy to answer anything.